Hi everyone. Today we're going to be doing the opposite part of the syllabus outcome that we did last time, and we're going to be calculating pOH. So our syllabus outcome is calculate pOH and hydroxide ion concentration for a range of solutions. Now, revision questions, make sure you've done these before you start this. So here's the answers. So pH is a logarithmic measure of hydrogen ion concentration. Each tenfold increase in hydrogen ion concentration decreases pH by 1 point. Our equations that we use, pH equals negative log 10 of hydrogen ion concentration, and the one that's not on the formula sheet, hydrogen ion concentration equals 10 to the negative pH. So pOH scale, so it's very similar to pH scale, but instead it's a measure of hydroxide ion concentration of a solution. So very similarly to our pH, at a pOH of 0, our hydroxide ion concentration is 1. And as we go up in the pOH scale, our hydroxide ion concentration decreases by tenfold until we get down to 14, which is 10 to the negative 14 moles per liter of hydroxide. Now, you'll notice how this scale, I've colored it like the universal indicator scale, and we can see that a pOH is very basic. Okay, so basically a pOH of 0 is a pH of 14. Sorry. Now solutions in this top area, they have increased because we've added. The pOH has decreased because we have an increased hydroxide ion concentration. So you can see there that it's above 10 to the negative 7. Our middle is a pOH of 7, which is where we have that self-ionization of water. And solutions in the bottom area have a decreased hydroxide ion concentration due to the addition of acids. The acids react with the hydroxide ion concentration there to lower the concentration of it. Okay. Now, the formula we use to calculate pOH is this. So pOH is negative log 10 of hydroxide ion concentration. Now, pOH is a unitless number representing basicity. Hydroxide ion concentration is OH minus in square brackets is obviously hydroxide ion concentration, and our log 10 is on our calculator. Now, this one is not on your formula sheet. The pH one is, but you just need to know for pOH, we sub out H plus for OH minus in this formula. Now, to calculate hydroxide ion concentration, we use a similar formula to the pH one. So hydroxide ion concentration is 10 to the negative pOH. Again, this is not on your formula sheet, so you'll have to remember it. So let's do an example. Calculate the pOH of a 0.1 mole per liter solution of magnesium hydroxide. So firstly, we need to do the reaction equation of the dissociation of the salt. So magnesium hydroxide gives us 1 magnesium and 2 hydroxides. Now, like with pH, we have to have a look at the concentration of the compound and compare it to the concentration of the hydroxide ion concentration. So here we can see that the molar ratio is 1 to 2. It means that the concentration of hydroxide ions is going to be double that of the magnesium hydroxide. So what we know that the concentration of hydroxide ions is double the concentration of magnesium hydroxide. And if our magnesium hydroxide is 0.1, then we get 2 times 0.1, which is 0.2 moles per liter. We can then plug that into our pOH equation. So pOH is negative log 10 of OH minus, which is negative log 10 of 0.2, which is 0.699. Now, pH and pOH. Apart from being inverses of each other, the pH and pOH scales are related. And the relationship is this. pOH plus pH will always equal 14. Okay, so the relationship itself arises due to the self-ionization of water. Now, water doesn't exist just as a liquid. Okay, again, this is one of those things where chemistry's lied to you a little bit. Water does ionize spontaneously, but only a tiny little bit, like that. So most of the water exists as liquid, but some of it exists as H plus and some exists as OH minus. The amount of self-ionization water is dependent on the amount of H plus and OH minus already in solution. Now, they're inversely related due to the ionization constant of water. So if we have a look at the equation on the previous page, water gives us H plus plus OH minus. If we find the KEQ for that, we get this. So Kw, which is always 10 to the negative 14 at 25 degrees Celsius, is the concentration of hydrogen ions times the concentration of hydroxide ions. So therefore, as the concentration of H plus increases, the concentration of OH minus decreases, because it always has to be that K value. It has to be that 10 to the negative 14. So, calculate the pH of a 0.1 mole per liter solution of sodium hydroxide. So again, we write out the reaction equation. Sodium hydroxide gives us 1 Na plus 1 OH minus. Now, pH requires hydrogen ion concentration, but we aren't given a value for that. We haven't added any acids, so how can we find the H plus? We were only given concentration of sodium hydroxide, and by extension the concentration of hydroxide ion, so how can we figure it out? Well, what we need to do, we know we've got a 0.1 molar solution of sodium hydroxide, but we need the pH. Molar ratio is 1 to 1. So what we can do is first calculate the hydroxide ion concentration. We can then calculate the pOH, which in this case is negative log of 0.1, which gives us 1. Now, that's pOH. We're after pH. So we used that relationship on the previous slide. So pH plus pOH equals 14. 1 plus a number equals 14. So pH is going to be 14 minus 1, which is 13. Okay, so if we had a 0.1 molar solution of sodium hydroxide, the pH of that should be 13. What is the pH of a solution that contains 2.38 grams of barium hydroxide dissolved in 250 mils of water? Okay, so now we're starting to get into the slightly more complex ones. What are we given? So let's have a look. We're given 2.38 grams of barium hydroxide, and it's dissolved in 250 mils of water. Okay. We're after the pH. And so what we have mass of barium hydroxide, volume of water, and we're looking for pH. So what can we do to get there? Let's have a think about it and draw a flow chart if you need to. So we have pH. We want pH. We have mass of barium hydroxide and volume of barium hydroxide. So what we need to do, for pH, we need the hydrogen ion concentration, but we don't have anything with H+. So we're not going to be able to use that method. The alternate way of calculating pH is using pOH, and for that we need the hydroxide ion concentration. Okay. For that we need the concentration of barium hydroxide. To get the concentration of barium hydroxide, we need the moles and the volume. And luckily we have mass. So what we can do is the number of moles and the volume can give us our concentration. But first we need to find the number of moles of barium hydroxide. So we can see our little flow chart that we have to follow. So we start with mass of barium hydroxide, convert it to moles, convert it to concentration, then convert to concentration of OH minus, find pOH, find pH. Let's get started. So number of moles of barium hydroxide's mass over molar mass. Mass we were given, molar mass we just have to calculate. It should give us 0.01389 moles per liter. Moles. Okay, so that's given us N. Now we need to use the volume of barium hydroxide to calculate the concentration. Okay, so it's the numbers, so 0.01389 moles from the previous page, so that shouldn't say grams, that should say moles. And it was 250 mils, so we need to convert that to liters, so 0.25 liters. Should give us 0.05556 moles per liter. Now, that's concentration of barium hydroxide. What's the concentration of the hydroxide ions? Well, write out the reaction equation. It's 1 to 2. So we're going to have twice the number of OH minus that we have of BaOH2. So it's 2 times that, which gives us 0.1111 moles per liter of OH minus. We can then take that through. So pOH is negative log 10 hydroxide ion concentration, which is negative log 10 of 0.1111, which is 0.9543. pOH plus pH equals 14. So 0.9543 plus pH is 14, gives us in the end a pH of 13.0457. So see how we worked through that? So we followed the flowchart, got to our answer. Okay, and just rounding it to 4 sig fig. Now, our summary. pOH is a logarithmic measure of hydroxide ion concentration, very similar to pH, but inversed. Each tenfold increase in hydroxide ion concentration decreases pOH by 1 point. This is our formula. So pOH is negative log 10 OH minus. Hydroxide ion concentration is 10 to the negative pOH. And lastly, the way that they're related, pOH plus pH equals 14. Remember, that comes from our Kw, which is 10 to the negative 14, and is our concentration of H plus times our concentration of OH minus. Okay, so that's all for today. Have a go at the questions, and I'll see you next time.